All right, so the second half of chapter 5, for the most part, we've been solving quadratic equations. We said there were 5 ways to solve quadratics. There's 3 ways that we learned so far. Graphing, factoring, and using square roots. If b equals 0, you can use square roots. The last 2 sections in chapter 5 are on the other 2 methods. Today we're using completing the square, and then on Tuesday, I guess it will be, we'll do section 5.8, which is the quadratic form. So solving quadratics by completing the square. To start out with, we're going to look at the following example. That's to solve the perfect square trinomial. There's a couple different ways we could do it. We could get it equal to 0 and factor it, and that's probably going to be the fastest way. But let's go ahead and solve it by completing the square, which is actually already been completed for. So if I wanted to factor the left side, how would it factor? X plus 5 and x plus 5. So I could write that as x plus 5 to quantity squared equals 36. If I'm solving for x, what would I want to do to both sides next? Square root both sides. When you square root both sides, remember x plus 5 could be 36, or it also could be 6, or it could be negative 6. And then what? Subtract 5. So then we get positive 6 minus 5 is 1. Negative 6 minus 5 is negative 11. That equals 1 or negative 11. So if we have a perfect square trinomial equation, this is called a perfect square trinomial. It's a perfect square because it can be written as something squared. Trinomial means 3 terms. It's pretty easy to solve. You factor it. If it's a perfect square trinomial, you should be able to write it as something squared. Square root both sides, and then in this case, subtract 5. The problem is, a lot of times it's not going to be set up as a perfect square trinomial for us already. So that's what we want to look at here in 5.7 is how to create a perfect square trinomial. So fill in the blank to complete the perfect square trinomial. That's where the phrase completing the square comes from. And rewrite as the square of a binomial. That's something squared. So x squared minus 8x plus 1. Do I remember how to do this? How to complete the square? If I remember doing this in the past a little bit. I know if you had Mr. Jones last year, Veronica, for one, you did it. We want to write this as x plus or minus something squared, right? What do we think that part might be? First of all, it's going to be x plus or x minus? X minus. Yes. X minus 4 is correct. If we did x minus 4 times x minus 4, wouldn't that give me x squared minus 4x minus 4x? And then what goes here? Plus 16. Obviously, we wouldn't have to just kind of guess and check at it, though, until we get it. How can I get the minus 4 and the plus 16 rather quick? Where does the minus 4 come from? How does it relate to this minus 8? It's half. Will it always be half? Yeah, because these two middle terms, x times negative 4 times x, that should be half of what is right here, right? So you're going to take the b term, divide by 2, and then do what to that when fill in the blank? square it. All right, so in this case, negative 8 divided by 2 squared gives me 16, and then from there I can get x minus 4 squared. So those of you that like having a little formula, b divided by 2 squared is always going to be what? Complete 2 squared. So it goes in the box. The b value divided by 2 squared. So part B, x squared plus 17x plus what? So we would do 17 divided by 2 squared. I don't know what 17 squared is. 289. So in the blank would be 289 over 4. Because 17 divided by 2 is a decimal. Because we don't have decimals in the problem, we don't want to write it in the decimal. So 17 halves squared, you can just square the top and square the bottom. And then if it wanted it as the square of a binomial, what would it be? X 1, 17 over 2. This was negative 8 divided by 2 gave us negative 4. 17 divided by 2 is 17. You do this one real quick. X squared plus 18x plus what? Fill in the blank so it's a perfect square trinomial. And also write it as the square of the binomial. Yeah. So like 18 divided by 2, since that comes out even, change that to 9. X squared plus 18x plus what gives me a perfect square trinomial? What goes in the blank? 81. And if we need to write that as something squared, what would it be? X plus 9. Any questions there? All right, so that's how we complete the square. Let's take a look at what we're going to do with that and how we can use that to solve a quadratic equation. First thing you always want to do, once it's equal to 0, is move the constant term over to the other side. So here we have x squared minus 12x plus 5 equals 0. So that plus 5, we're going to move out of the way. Notice this is not a perfect square trinomial. We can't write it as something squared. If we tried to solve it by factoring, we wouldn't be able to. So we want to get that plus 5, subtract it from both sides, move it over to the other side. So we're going to leave a blank there so we can complete the square. Next thing we can probably do is figure out what goes in the blank. What is it? 12 divided by 2 is 6. Squared is 36. When you square a number, it's always going to be plus. Because whether you had a negative number squared or a positive number squared, it's always going to be plus. So when you complete the square, it's always going to be plus. So 36, everybody okay with that being 36? Can I just add 36 to the left side? I can, as long as I add 36 to the right side also. Even say right there, don't forget, anything you do the left side of the equation, you have to do exactly the same thing to the right side. assuming we completed the square correctly, the left side we can now rewrite as the square of a binomial. What squared? X minus 6. The right side I can just simplify there. -5 plus 36 is 31. And now it's just like the very first example we did. A binomial squared equals a number. So the next step would be to square root both sides. And then add 6. X equals 6 plus or minus root 31. Questions on how we got that? If root 31 can be simplified, you need to. 31 prime, though. We can leave that one alone. What's the difference between that answer and this one here? Because I see some people write it like this. Those are not the same thing. What are we doing to the 6 and the root 31 here? We're adding them and then we're subtracting them, right? Here we're multiplying them first and then making it positive or negative. These two things are not equal to each other. Don't write that through. That's it. That's unfair. Any other questions before we move on to that, Helen? Solve by completing the square. X squared minus 8x plus 36 equals 0. X squared minus 8x plus 36 equals 0. What's the first thing we should do? Even before that, move the 36 over to the other side. And then I can do that 8 divided by 2 squared gives us 16. So add 16 to the left, also add 16 to the right. Rewrite the left side as the square of a binomial. And combine your terms on the right. Square root both sides, making sure we remember to include a plus or minus. No. That's when you do -8 divided by 2, you get -4. -4 squared, -4 times -4 is a positive 16. Yeah, when you complete the square, you'll always get a positive number. Square root of -20 can be reduced. We did that in the last section. It's a complex number, it's an imaginary number, but that's okay. Should be plus or minus 2i root 5. Everybody okay with reducing that to 2i root 5? Any questions on doing that? And then the last step, add 4. Four and the 2 cannot be combined at all. If this one has an I root 5 on it, the 4 does not. That's your answer. Questions on doing this?